Alright, so let's try another example where we're trying to find the rational roots. Directions tell us to use the rational roots theorem to find any rational roots. If it has at least one, solve it completely. So remember, what we do is we take our factors of our constant. Top number is always the one on the end, so factors of 12, and we divide it by factors of our leading term, which is a 1. So here's what I'm looking at, that last term of 12, and in front of the x cubed is a 1. So let's list our factors of 12. It is positive or negative of all the factors we come up with. Factors of 12, let's see, 1, 2, 3, 4, 6, and 12. And let's just make sure these should be factor pairs. 1 times 12, 2 times 6, 3 times 4. All over our factors of 1, just a 1. So really, the factors, or the factors we're going to check to see if they are zeros are, if you divide all those by 1, you just get 1, 2, 3, 4, 6, and 12. Alright, so then what we do is we take our synthetic division and we just try them one at a time. All the positives, all the negatives, and hopefully we'll find one that works so that we can divide this down from an x cubed to have that quadratic. So if we get it down to a quadratic, we have great ways to solve this. So let's try the 1 first. So with synthetic division, we take our coefficients up there. X cubed has a coefficient of 1, x squared has a negative 4, x to the first power is negative 3, and our constant is 12. Alright, then we add down, multiply, add down, multiply, add down, multiply, add down. Alright, so do you see how we got a 6 here? If you get a remainder, that means that 1 was not a root of our polynomial. So we try the next one. Let's try 2. So same thing again. We already wrote the roots out. The coefficients out. 1, negative 4, negative 3, 12. We want to find a factor up here that when we do our synthetic division, we get that 0. Alright, so we add down, multiply, add down, multiply, add down, multiply, add down. This one did not work. So what do? We move on to the next one. We've tried 1, 2, now we're going to try 3. So 3, 1, here's our coefficients, 1, negative 4, negative 3, 12. Add down, multiply, add down, multiply, add down, multiply, add down. We did not get a 0, so that one did not work. So we're moving on to 4. Here's our coefficients again, negative 4, negative 3, 12. So sometimes if you look at, we have 1, 2, 3, 4, 5, 6. All positive, all negative. There are 12 possible factors that we'd be trying here. So we're just keeping our fingers crossed that we get one that works sooner than that. So we add down, we multiply, add down, we multiply, add down, we multiply, add down. This one worked out. Alright, so because we got that 0, the remainder, that means that that factor of 4 is a root. So x equals 4. That's one of our answers. How does that help us? Well, because we were able to divide it down, now we have, here's our constant, here's our constant, here's our x, and here's our x squared. So 1x squared plus 0x minus 3 equals 0. Alright, so let's take a look at this. Are there factors of negative 3 that add up to that middle term of 0? No, there's not. So we can solve using the quadratic formula. You can always use the quadratic formula if you can't factor it. However, in this one, if you notice, we do have an x squared, and that's the only x. That means we can treat it like an equation and just get that x squared by itself. Let's go ahead and add 3 to both sides. So this is what we call solve using square roots, and it only works if you have only the x squared. Now we square root both sides, so x equals, remember, it is a positive and a negative, square root of 3. So we used our rational roots theorem to get us 4. 4 is one of our answers, and it got us down to a quadratic. Now that we have the quadratic, you can solve by factoring, quadratic formula. We solved using square roots. So we have a positive square root of 3 and a negative square root of 3. And you could have written those together as well. But those are our three roots of our polynomial.